Hello viewers, welcome back. Welcome to the second aspect of this question. It says a given quantity of electricity was passed through three electrolytic cells connected in series containing solutions of silver nitrate 5, copper 2 tetraoxide 6, and sodium chloride respectively. If 10.5 gram of copper is deposited in the second electrolyte, calculate 1. The mass of silver deposited in the first cell, and 2. The volume of chlorine liberated in the third cell at 28 degrees C and 742 millimeters of mercury. Now, in our last video, we tackled the first question. We calculated the mass of silver deposited in the first cell. We also calculated the quantity of electricity required, which was 31,913.4 coulombs. Now, in today's video, we're going to step into the second aspect of this question, which is the calculation of the volume of chlorine liberated in the third cell at 28 degrees C. This is the temperature, and of course pressure, 742 millimeters of mercury. Now remember that the quantity of electricity from our previous solving was 31,913.4 coulombs, and a halving for 2 moles of chloride ions will migrate towards the anode, liberating chlorine gas, 1 mole of chlorine gas, and of course releasing 2 electrons. So that is a half-cell reaction, the anodic half-cell reaction for chlorine. Now, so 2 Faradays will be required. So let's try to relate it mathematically to see. Now, 2 Faradays will be required to liberate about 22.4 cubic dm. That is the molar volume of gas at STP, the molar volume of gas at STP, 22.4 cubic dm. Now, if 2 Faradays is required to liberate this volume, then 31,913.4 coulomb will liberate how many cubic dm of chlorine gas? And that is what you're trying to do. Now, we don't know the volume yet. Let's call it Y. So by relating this mathematically, we're going to cross multiply, and then from there, we're going to find our Y. So once we cross multiply, our Y will be equal to now we have 2 times 96,500 coulomb, because 1 Faraday is equal to 96,500 coulomb. So 2 Faraday will be equal to 2 times 96,500 coulomb. So our Y will be equal to 31,913.4 coulomb multiplied by 22.4 cubic dm divided by 2 times 96,500 coulomb. So if you check this using our calculator, our Y is going to be equal to our Y will be equal to 3.704 cubic dm, and that means 31,913.4 coulomb will be required to liberate about 3.704 cubic dm. That is. Now the question says we should calculate the volume of chlorine liberated in the third cell at 28 degrees C and 742 millimeters of mercury. Now, let's call this volume V1. Let's call the volume liberated at STP. Let's call it V1. Let's call the volume liberated at STP by this quantity of electricity. Let's call it V1. Our V1 now will be equal to 3.7 0.04 cubic dm, and I've converted the cubic dm to cubic cm, and we have 3,704 cubic cm. Now our P1, that is P1, our P1 will be equal to our P1 will be equal to 760 millimeters of mercury. 760 millimeters of mercury, that is the standard pressure. And our P2 our P2 will be equal to 742 millimeters of mercury. Millimeters of mercury. Our T1 is equal to the standard temperature and is equal to 273 Kelvin. Our T2 will be equal to 28 degrees C. But this temperature is in degrees Celsius, so we need to convert it to Kelvin. And how do we do that? By adding 28 to 273. So if we add this up, we're going to have 301 Kelvin. So our T2 is equal to 301 Kelvin. So we have the value for V1, we have the value for P1, we have the value for P2, we have the value for T1, and of course for T2. What we do not have is the value for V2. V2 is unknown, and that is exactly what the question, is asking us to find V2. And how do we find V2? It is very simple. Viewers all over the world, this question has taken us back to gas laws. And of course, we are going to use the general gas equation to find V2. I'm going to write the statement of general gas equation, and then from there we can solve the problem. Now, this is general gas equation. The mathematical statement says P1V1 divided by T1 is equal to P2V2 divided by T2. Now, we have the value for P1, we have the value for V1, of course we have the value for T1. We also have the value for P2, of course for T2, and we're looking for the value of V2. And we're going to make V2 the subject of the formula. Now, how do we make V2 the subject of the formula? By simple cross multiplication of this equation. So once we cross multiply, we're going to make V2 the subject of the formula. So let's do it right away. Once we cross multiply, we're going to have this, and P2V2 T1 is equal to P1V1 T2, and then we're going to make our V2 the subject of the formula by dividing both sides by P2 T1. So our V2 is equal to P1 V1 T2 divided by P2 T1, where P1 is 760 millimeters of mercury, V1 is equal to 3,704 cubic cm, T2 is 742, T2 is 301 Kelvin, P2 is 742 millimeters of mercury, and T1 is equal to 273 Kelvin. So viewers all over the world, we're going to take this solution right away. We're going to solve this right away now. Now let's put in the values for P1. Of course, let's put in the values to find our answer. So this is what we have. We have succeeded in substituting the values. We have 760 times 3,704 times 301, all divided by 742 times 273. So if you check this out, using our calculator, we're going to have 4,182.96 cubic cm. So our final answer is 4,182.96 cubic cm, which can be approximated to 4,183 cubic cm. And that is the volume of chlorine liberated in the third cell at 28 degrees C and 742 millimeters of mercury. So we have succeeded in solving an electrolysis problem combined with gas laws. If you are interested in this kind of videos, don't forget to like and share. Also subscribe to my YouTube channel, MST Online Class. Follow me on TikTok, MST Online Class, and of course on Facebook, MST Online Class and MST Komahagbe. Thank you so much for watching, and God bless you. See you in the next video.